Question 2a. Sulfur chloride, SCl2, is a liquid at room temperature. When sulfur chloride is added to water, misty fumes are seen, and a solution is made that turns universal indicators red. So this one, of course, you need to know when universal indicators turn red means it's acidic. So means the fumes that produce must be acidic fumes because it would form acidic solution. Then the fumes, of course, is the HCl fumes, white fumes. Okay. Part 1. Identify the types of reactions that occur when the sulfur chloride is added to water. Okay, because the reactions involve water, so this type of reaction, of course, is hydrolysis. Right? So if a reactions involve water, so most likely we can say that is hydrolysis. Right? So because it reacts with water and form other products. Part 2. Name a chloride of different period 3 elements that also liquids at room temperature and produce the misty fumes when added to water. Okay, this one is quite easy. It's a SiCl4. Of course, you cannot give the formula. It's asked name. So you just put silicon tetrachloride. Okay, that's the name, SiCl4. Part B. A molecule of SCl2 contains 2 SCl covalent bonds. Completes the dot cross diagram in this figure 2.1 to show the arrangement of electrons. Of course, first you need to count the total electrons that involve. Sulfur is group 16, so it has 6 valence electron. Chlorine is group 17, okay, it has 7 valence electron. So because we know that now is SCl2, means the total electrons must be 20. 7 plus 7 plus 6. Means in the dot cross diagram, you must make sure there are 20 electrons there. So because it's already told you it contains 2 SCl covalent bond, means you need to draw the dot cross between this sulfur and chlorine to show that there is one covalent bonds and another covalent bonds. Right. So put a dot cross here. In this diagram, you need to follow the instruction. The dot is electrons from sulfur. The cross is electrons from chlorine. So means here you need to put another 4 dots. So means total 6 electrons from sulfur. And for the chlorine, okay, after these electrons that share, you need to draw another 3 pair of electrons on each chlorine. That means 3 lone pair here, right? So total 6 electrons here, plus these electrons is 7 electrons from chlorine. Okay, normally dot cross diagram, okay, if you able to complete that, you can at least get 2 marks. Part 2. Predict the shape and the bond angle in this SCl2 using this valence electron pair repulsion theory. So first, you need to know which one is a central atom. Okay, obviously sulfur is a central atom. And the sulfur has 2 lone pair and 2 bonding pair. Normally, the lone pair will not really involve in this geometry or shape. So therefore, we will just consider the atoms. So because the repulsion of this electron pair this electron pair is still there, and this lone pair and this bonding pair, they will repel each other, right? So, and the repulsions of the lone pair is stronger than the bonding pair. That's why the bond angle between this chlorine, sulfur chlorine is 104 or 104.5, which is not same as this tetrahedral geometry, which is 109.5 degree. So if it's a tetrahedral geometry, the bond angle is 109.5. Because the repulsions of the lone pair here is stronger, it will compress this bonding and make the angle smaller, right? So it will become 104.5 degree. So this is kind of quite similar with the water that you learn, right? Okay, part 2, predict the shape and bond angle. This is very easy. So means this is non-linear. Means in this geometry or shape, as I told you, we just consider this atom. So we just use the chlorine, sulfur, and chlorine. So what you can see here is non-linear. Okay, last time we call V shape. In the latest syllabus, we just use non-linear. And the bond angle, of course, you can put 104 or 104.5 degree. Part C, solid magnesium nitride is a crystalline solid. Deduce oxidation numbers of magnesium and nitrogen in this solid. Very easy. When the magnesium is formed compound with others, because it's group 2, it's always positive 2. This is for sure. Therefore, we know that 3 magnesiums inside this formula, so means it's going to be positive 2 times 3, so it's positive 6. Means nitrogens need to be negative 6, because the whole compound is neutral. So when it's negative 6, then we need to divide by 2, because there are 2 nitrogens here. So means negative 6 over 2, the oxidation number of nitrogens must be negative 3. Right? So this is the answer, oxidation number of this magnesium and nitrogen. Part 2. Magnesium nitride reacts with an excess of water to produce ammonia and magnesium hydroxide only. Construct equations to describe this reaction. This is very easy. You just use the formulas that given. With water, form these 2 compounds, magnesium hydroxide and ammonia. Then you just balance it. So you get this. Part 3. Explain why the solutions produced in the reactions C2 has a pH greater than 7, means is alkaline solution. So why the solution is alkaline? Of course, most likely it because of hydroxide. So you can actually explain using the 2 products, either one of these products. Normally we will use ammonia because easier. When ammonia reacts with water, right, we know that it will form ammonium and hydroxide. So that's why ammonia solution is alkaline solution. Okay, because hydroxide always produce. Or you can actually use the magnesium hydroxide, which is slightly soluble. Solubility is quite low, but it still produce a small amount of hydroxide, right, which will make the solutions alkaline. Okay, so therefore your answer, okay, first must be this is due to the presence of hydroxide solution, and you can explain the acid-base reactions between ammonia and water, because ammonia gains the protons from water and form ammonium, so water will form hydroxide. Or you can say dissociation of some of this magnesium hydroxide, which will also produce the small amount of hydroxide in the solution. Okay, part D. These structures looks like quite complicated. actually it's not. Okay, so we have this boron nitride. It's a white solid melt above 2900 degrees C, okay, now the black particle is boron, so the white particle is the nitrogen atom. And between the layers, you can see this is one layer, and this is another layer. Between the layer, so we know that is intermolecular force, which is the van der Waals force. So between layers, there are van der Waals force, and between the atom inside this layer, so it's a covalent bond, right? So this is very similar to what? To the graphite. And okay, let's look at what is the question? Use this figure to deduce the empirical formula of boron nitride. So you need to know the ratio. Let's start with the nitrogen. Okay, so just observe carefully. Let's use this nitrogen. Okay, this nitrogen is bound to the 3 boron, as you can see. And now let's use the boron. Okay, here, let's say this boron also bond to 3 nitrogen. Means the ratio between the boron and nitrogen is actually 1:1, because each of these elements they bond to 3 these atoms. Means nitrogens bond to 3 boron, and the boron bond to 3 nitrogen atom. So from this structure, we know that their ratio must be 1:1. And therefore, when they're 1:1, the empirical formula must be Bn. 1:1 ratio, right? Part 2. Suggest the identity of another crystalline solid that has the atom arrangement in layers similar to this boron nitride. Okay, as I told you just now, is very similar to graphite. Okay, that's all. Thank you.